Let's prove the chord-central angles theorem, which tells us that if two chords in a circle are congruent, then they determine two central angles that are congruent. Let's have this illustration here. We have chords AB and CD of the same circle O, where they are of the same measurement. We need to show that these central angles, angle AOB that will be formed later, is congruent to angle COD, as these are the angles determined by the given chords. In order for us to do this, let's have here the two-column proof for statement and for reason, and let's hope that from here we reach this statement, the goal of this video. Let's start, of course, by placing what is the given. So we have here chord AB or segment AB and segment CD are chords of circle O, okay, where they are congruent. And of course, the easiest reason is that this is what is given. We need to apply necessary skills, especially with the relationships of different figures and shapes, in order for us to reach this intended outcome, as this corresponds to our statement, so central angles are congruent. I would like us to start by constructing radius or radii. Let's construct radii OA, OB, OC, and OD. And this is possible because O is the center of the circle, and when we connect that center to the points A, B, C, and D on the circle, we will come up with radii or radius. So this is by construction. So we need this because in our given figure, angle AOB and angle COD are not observable. But by doing this, we have segment or radii OA, OB, OC, and OD. So we have now developed this angle here, AOB and COD, so that we could establish this relationship. Now with that, our goal is this. So let's have this third step. The third step now is, since we have two triangles, we are going to establish that the two triangles formed by step 2 in the given are congruent, so that we could apply the same concept with the central angles developed here. Okay, so in this case, let's have, since this is on radius, let's also apply here the continuation. That's this in connection with step 2. So we can establish here that segment OA is congruent to segment OB, okay, and congruent to segment OC, and so also congruent to segment OD. The reason for this is that they are all radii of the same circle, and we have that statement that radii of the same circle are congruent. Okay, we did this later, and we simply place it here so that this will be connected to step 2. But of course, we need this later to show our proof here. But since we are on angles, let's try to mention what happens now to our angles here. Okay, just for the purpose of this, okay, let's have here the definition for the central angle before we could come up with the congruence. Okay, so this would appear on our proof, not just on the last step. So since they are all radii, this is actually supposedly connected to step 2, but we just simply entered step 3 here, so it would be on logical process. But this could also be integrated in step 2. Step 3 rather. I just placed this as step 4. We have here angle AOB and angle COD. These angles are central angles. we need to establish this statement because what is given here on our the item we're trying to prove is central angles. So let's also try to make sure that they are central angles. And since we have established that the sides of AOB, that's OA and OB, as well as for angle COD, OC and OD, are radii of the same circle. So this is true per definition of central angles. Okay, now that we have that, we have introduced already the angle AOB and angle COD. Let us now proceed to showing the relationship of the two triangles here. So we have here, automatically we'll have a triangle there, but since we are trying to show this, how do we do this one without introducing triangles? So we can establish here that for the first statement, this chord AB is congruent to chord CD. Okay, and then on our third statement, according to this reason, OA is congruent to OC. Okay, and then we have here OB is congruent to OD. So we have shown three different sides, corresponding sides, which are actually congruent to one another. So we can now establish here triangle now. Triangle AOB is congruent to triangle COD. This is because these are all congruent to one another. And again, we have here this relationship here. Segment OA is congruent to segment OC. Segment OB is also congruent to segment OD. So we have established SSS. So these triangles are congruent according to SSS postulate. Okay? Because, again, the first side, the chords A, B, and C, they are congruent by given. Then we have established the radii are also congruent. So we have two congruent triangles according to the SSS postulate. We're doing this because when we go to our step 6, and we have established already angle AOB and angle COD being part of those two, we can now say that angle AOB is congruent to angle COD. This is under CPC TC, or corresponding parts of congruent triangles are also congruent. This means that once we have established that the triangles formed are congruent, angles AOB and angle COD being the central angles, they are also congruent. Now, this is the end of our proof showing that our two central angles that are developed here are congruent, and that is the purpose of this video. This is now the proof for the Chord-Central Angles Theorem, and this will now be used in our classes because this is already proven, which states that if two chords in a circle are congruent, then they determine two central angles that are congruent as well.